Welcome back to Chapter 7 Interfaces. And this is the part 3 of Chapter 7. In Chapter 7, we have been discussing about the importance of interfaces in the human computer interaction. Interfaces plays an important role because it lets the user interact with the system by using different interfaces. Hence, we have seen that there are 22 types of interfaces introduced in this chapter. The part one of this chapter included the interfaces like the command prompt CLI command line interfaces, which have the list of commands to display the contents inside the system. Then, wherein the next evolution over the CLI was graphical user interface, wherein the user had the opportunity to do the work by using the options given in the interface in the form of checkboxes or buttons. He doesn't have to now remember the command line prompts to do the some work like how they used to do it at the time of CLI. Then we had the graphical user interface evolved by taking the interfaces that are supported by web-based systems. Okay, so if you have not seen this video, you can quickly go and do watch the first part of this chapter 7. In the in the part 2 of chapter 7, we have talked about interfaces that included virtual reality. We also talk about multimedia interfaces, and then we talk about mobile interfaces, and then we talk about the special type of a special way of displaying the web interfaces by using the breadcrumbs, wherein it is easier for us to understand that we are actually viewing the product. I hope. Why is it not cursor being checked? We're able to see the cursor. Why? Okay, let me take a pointer. So, wherein we were talking about the breadcrumbs, right? The breadcrumbs inside a web page helps you to locate easily to the page where you have come from. For example, if you're viewing a product information, it means you have clicked on home, then you have clicked on smart home, then smart lighting switches and plugs, and then smart lights, and then the product information. So it is easier for a user to track or trace back from which place he has landed up to the exact one. We have also seen some home appliances and their interfaces. For example, the bread toaster here have the intensity regulator, and then also it has the start and the automatic stop of grilling the bread. So we have talked about the mobile interfaces. So this was covered in the part 2 of chapter 7. So if you have not seen, you can go back and check with the second part of the chapter 7 interfaces. Now we're going to talk about the voice interfaces. Voice interfaces involves a person to talk, okay, in a particular spoken language app. And it becomes very easier for the user to talk and get back the answer. For example, we have Siri in these days from App Store. We have Alexa from Google Play. It helps us in doing or in knowing, about the weather, for example, in a very easy way. For example, you can talk to the app and find out what is the timetable, what is your timetable, what does your timetable looks like for tomorrow. You can travel a planner, you can plan travel, and you can do some phone services or use a chatbot by using the voice commands. Voice commands are supported by voice enabled interfaces. Now we will see what are the research and design concerns that comes when we want to have an app equipped to handle the voice of the user. The first important thing is the spoken language, which tells that in which language the app has to be made to support it for. For example, there are some apps that supports Arabic. Some apps supports English, and some apps are so mature that they support multi languages. For example, Alexa supports many languages, and Siri also supports a lot of languages. They are mainly used for the inquiring about specific information. For example, the flight timings to perform a transaction such as buying a ticket. Mostly the voice systems are reactive. It means the user initiates and the system responds. For example, you can ask the Siri, what's my timetable tomorrow? So it's like you are the first one to talk, and Siri is going to tell you what is your timetable tomorrow. So such type of systems are called as reactive responding. It means they react and then respond. It means the user has to initiate and then they respond back. Also used by people with visual impairments, the people who cannot see, it's very good for them. It's very easy for them to handle. For example, they also have speech recognition, word processors, scanners, web readers, and home control systems. Here, the picture is given with the system, and the user is trying to talk to the system, and then the system is trying to identify who is talking. Okay, have speech interfaces come from ages? We would like, back days, if you note, if you remember, your cartoon systems like cartoons and small kids play web series or something. They used to have certain kind of things inside it wherein the user used to talk. Or Ben 10, I believe, it's a character, right? It's a kid's character that talks to the that talks to the watch, right? That talks to his watch, and watch does so many things. So the idea is anyhow older, but now being implemented. Modeling human conversation often is very special to handle. For example, people often interrupt each other in a conversation. For example, when you're talking with your friend, so a third person can come and talk in middle of you, right? So people, in one-to-one conversation also, they interrupt, they disturb each other. For example, you start a question before the other person takes the turn to talk. You either take longer time to complete your question, or the other friend interrupts you in the middle of your talk. Okay, so interruptions are always there. Then how these interruptions should be handled when you're talking to the system, because the system will get confused here, right? So that is the reason why when we talk to Siri, okay, and then if there are two voices coming in the same time, then it says, please repeat the question, I cannot understand. So such type of things has to be handled, because modeling human conversations are not very straightforward. Okay, here an example is given, especially when ordering in a restaurant. Rather than let the waiter go through all the options, you interrupt and you talk more about it. Speech technology has a similar feature called as barge in. Barge in is like, you are, yeah. See, for example, if two persons are conversing with, when two users are speaking with each other, okay. An ideal conversation is like when the first one speaks, the other one hears. Then the other speaks, the first one hears. This is the ideal situation. But because human modeling is, a bit complex, it can happen in whatever way these two users want. For example, the first user is talking, the second is interrupting. Similarly, the second started talking, the first one is interrupting. So, in order to handle such type of interruptions, the speech technology, have something called as barge in. This is very important term. Barge in. What does it do? It allows the user to choose an option before the system has finished listing all the options available. So it's, for example, it's like you are asking your Siri in your iPad to list what are the restaurants nearby the university. It starts listing 1, 2, 3, 4. Now there are, for example, there are 10 restaurants near the university, and now before it completes listing all these 10 options, you barge in, you get in the middle of it, and then you start talking about or inquiring about restaurant number 4. So are you understanding? So before even the system finish listing its available options, you are barging in, hopping in the middle of the listing or the conversation and asking something else. So the technology is designed nowadays to handle such types of interruptions. How should the structuring of voice dialogues should be done? There's something called as directed dialogues, and there are something called as more flexible systems, and there are something called as guided prompts. Now let us see what all these three refer to. Directed dialogues are where the system is in control of the conversation. So here the system is controlling the conversation, where it asks specific questions and requires a specific response. If the response is not given precisely, then it will ask the question again and give you a hint, but it is not accepting your wrong answers. More flexible systems allows the user to take the initiative. Here, the system keep quiet, and then, for example, it will say, "I would like to." For example, you say, "I would like to go to Paris next Monday for 2 weeks. Now, can you plan, some picnic for me, or a conference for me, or some, productive day for me?" So some systems are allowing the user to take the initiative. Some systems are taking the complete control. Now, what are guided prompts? Guided prompts, ChatGPT is the best example of guided prompts. Uh, Guided prompts can help caller back on the track. For example, "Sorry, I did not get all that. Did you say you wanted to fly next Monday?" So it's like, guided prompts are, making sure from the user that this is what they understood from the prompt. And if it is yes, then the system will start working and trying to help you out with the voice conversations. Now, voice assistants, for example, Alexa or Siri, are like allowed all to use rather than being single use. Yeah, for example, I have my iPad. My kid can talk to Alexa. Siri, sorry. iPad has Siri, right? So my iPad can be operated by any of my, a home member or my friends, and this voice assistant can help anyone, right? So support families, playing games, interactive storytelling, jokes, and so forth. It encourages social and emotional bonding as well, right? You say "I love you" to Siri, and it tells you back. You say something, not good, then it responds you back by saying that, I am not supposed to answer you like that. So young children, usually under 4, they find it difficult because they cannot understand what the, voice assistant is trying to say, or the voice assistant is not that much maturely designed to handle the queries of 4-year old kid. For them, it's like quite frustrating. Okay. What are the research and design considerations? So this actually, for every interface, if you notice, there are research and design considerations, and this is actually our area of our area to evolve, or our area to make it mature. For example, as an HCI professionalist, what are you going to contribute to the voice interfaces? This is the place where your expertise is needed. Like how, for example, such voice assistants, how to design that systems that can keep conversation on track. I hope you're seeing my screen. Okay. So, how to design systems that can keep the conversation on track? This is the challenge. For example, we said that, modeling the human conversation is not very easy. It is complex. One can, while one is talking, the other can interrupt, and so forth. It can happen like that. So, how will you keep the conversation on track? help people navigate efficiently through a menu system. For example, if the voice system is listing you things in a form of a menu, how will you make it easily? For example, this happens when you are trying to call the help line of any airlines or any company. They tell you, this is an automated call. Your call is recorded, and then click, press one to do something, press 2 to do some another thing, press 3, press 4, press 5, and press 9 to talk to an executive. Then when you go there, it will ask you, if it is a bank, it will ask you whether you want to talk about a credit card or a debit card. If it is credit card, do the following things. If it is a debit card, try to do all the other things. So the menu systems becomes a bit complex, right? So enable you need we need HCI professionals to make this navigation easier, enable them to recover easily from the errors. If there have been some errors in the conversation, then we need to make up from these errors quickly and easily. Guide the users whose instructions are very general or vague or confusing in their request. So, how will you help them? So, these are the places wherein we still need the research and design considerations to evolve. So, as an HCI, what is your contribution going to? How will you make these three challenges easier? Okay, think about it. And this is your activity, and you're going to write it and upload it in the Blackboard. Type of voice actors, for example, should it be a male voice actor, or should it be a female or neutral, or it should be recorded dialect? Do people, you have to understand that, do people listen to what type of voice? For me, do they prefer male voice or female voice, or a northern or a southern accent, or an American or a US accent? So you have to be careful while, making a voice interface for a particular, targeted audience. You need to understand the preferences. What type of the language do they want? Do they want a formal language, or do they want an American English, or a UK, or a male or a female one? Now let's talk about the next type of interface, which is called as a pen-based interface. Many of you are using already smart pens in your iPad while taking notes, right? And while taking lecture notes or while drawing. Very easier thing, very flexible, right? Okay. It will enable people to write, draw, select, and move objects at interfaces using light pens or stylus. It capitalizes on the well-honed drawing skills developed from childhood. It becomes very easy to draw with a smart pen, right? Smart pens use a combination of ordinary ink pen with digital camera inside it. It can digitally record everything what the pen is writing on a special paper. If you see whatever you wrote, you can just save it and share it with others. So recording button is also there. This is an example of Live Scribe Eco to Smart Pen. Advantages, there are many advantages of using. Can you survive one day of, your college classes where it is very important? Can you survive one day without your iPad pen? It becomes very difficult, right? Because it is helping you in doing so many things. It allows people to quickly annotate the existing document easily and quickly. Fill in paper-based forms that can be readily be converted to a digital record using a standard typeface. So you type, you can convert it into you draw or you write by your hand. It can be easily converted to a typeface, and a type kind of a thing. So it can be easily digitalized, yeah, in a more perfect manner. Can also be used by remote teams to communicate and work on the same document. So you can have a same Google document open and everybody can start working on it from different places. The other very easiest thing that we are using, almost all of us are using, is the touch screens. We have laptops with the touch screens, we have smart boards with the touch screens, we have mobile phones with the touch screen, and almost everywhere we see the touch screen. What does the touch screen have inside it? It has a single touch screen. It has a multi-touch surface. Now, what happens? Single touch screens are used in walk-up kiosks such as ticket machines and ATMs to detect the presence and the location of person touch on the display. So where you touch, based on the touch screen, based on the point of the touch screen, the system identifies that whether the person who is trying to take money or do some ATM transaction is trying to take money or is just trying to print the receipt of the money. So based on the place of the touch screen, the systems can find out this. Multi-touch surfaces support a range of more dynamic fingertip actions. For example, sweeping, flicking, pinching, pushing, and tapping or zooming in and zooming out all are possible by using multi-touch surfaces. They do so by registering touches at multiple locations using a grid. You see, how is that possible? How does the touch screen system know that the user is trying to zoom in or zoom out? Because it internally have a grid inside it. So this internal grid, registers your touch on the screen, and then it helps the screen to understand, or the touch screen or the smart system to understand that the user is trying to do certain action like zoom in or zoom out. Now used for many kinds of displays such as smartphones, ipod, tablets, and tabletops. It supports one hand and two hand gestures, including tapping and zooming, stretching, clicking, dwelling, and dragging. All are possible. What are the research and design considerations? It provides fluid and direct styles of interacting involving freehand and also pen based. So you can operate your mobile phone by, if it is a Samsung Note series, then you have a stylus also coming with the phone, but many of them doesn't also need a pen. It can help you operate by simple finger touches as well. More design concerns include whether the size, orientation, shape of the touch displays affect collaborations. It is faster to scroll. Gesture needs to be learned for multi-touch. For example, you need to know how to zoom in and zoom out and tap and take a screenshot on different type of devices. So it needs a bit of learning. Uh, Sometimes it becomes cumbersome, error prone, and slower to type using virtual keyboards on a touch display than using a physical keyboard. Sometimes, yeah, when you have to type something by using a keyboard on the touch screen, then it becomes bit difficult.